Hello, welcome to the lecture on circularity indicators. I wanted to cover three topics for today. One is the circularity indicators, one is eco-design, and one on circular business models. So instead of putting everything onto one lecture, I have split all these three into three different videos. On circular business models, especially, I'm going to use what's called as flipping the classroom approach. Basically, you will be the teachers, you will be reading a lot about circular business models yourself, and then I'll give you an assignment specifically on discussing circular business models inside our forums. I hope to make the assignments mandatory, at least for circular business models, so we can stimulate a lot of discussion on it. So please do take part in the forum, at least for CBMs. And let's go to the first topic of the day, the circularity indicators. So this will be the structure of the lecture. We will first discuss about what are indicators. So what are the roles of the indicators, and then we will go to the classification of these indicators. So we will talk about what's called as the taxonomy of the indicators. And then I found something very interesting for you. There is this researcher who came up with an Excel sheet of finding the right indicators. I'll explain a bit about how to use that Excel sheet, and then we will see a small example of this use of such a circularity indicators. So let's get into the topic of what is an indicator and what are the roles of indicators. I remember during my undergraduate, professor asked me a question. I forgot exactly on what, but I just told him, oh, this particular thing has a longer charging time than the other. Then he immediately stopped me and asked, how long is long? So you should also ask the same question about something which is claimed to be circular. So how circular is circular? So that's a really important question. So indicators play a role in explaining or trying to answer this question of how circular is circular. So they are trying to give you a condensed form of information. So the real circular economy is quite complex. So indicators try to summarize its essence and condense complex information into meaningful knowledge, into something that we can easily understand when we look at it. And usually indicators are very useful as policy making instruments. So we try to say, oh, this is the amount of CO2 that we have to reduce before we can cross a 1.5 degrees Celsius GMST, right? So similar to that, we could also use some of the circular economy indicators to say that if we could stick within these boundaries, then we could assure that something is circular or not. And then also it's used as a tool to raise public awareness, right? So once you put a quantitative or a sort of qualitative target to something, then we say that, oh, this is sustainable and this is not, this is circular and this is not. And that's how the public could also track it, and then they could argue for remaining sustainable or remaining circular. So one important thing is that we can also measure our progress. So imagine that we are in a particular point of time in history, and we put up quantitative targets. So saying that we will reduce emissions by 70% is a quantitative target. So similar to that, we can put exact quantitative targets, and then we can measure our progress. Okay, so in this lecture, first we are going to see the taxonomy of indicators, or the classification of indicators. Over a period of time, people have developed many indicators to indicate circularity. So you see here a compilation of 55 of those indicators that is covered in this particular article that I'm trying to explain to you. So some of these indicators we will see later, for instance, recycling rates, end of life, RR, recycling rates. When we cover recycling, we will find a lot of circularity indicators in there. I'll try to explain to you what they are. But obviously we cannot go through every single indicator here. That's not the objective of this course. But what's the objective of this particular part of the lecture is that, let's say you are a business unit head, right? Or let's say you are a CEO, and a policymaker comes to you and asks you, look, is your business really adhering to the principles of circular economy? Are you really a circular business model? Or how can you make your business circular? Or they ask, okay, you say you are a circular business model adhering firm, but what are the consequences of what you have done? Has it really effectively contributed to circularity? So if a particular section of people asks you these bunch of questions, or let's say you are a circularity consultant in the future, and a business unit comes to you and asks you, how can I make my business more circular? So the first thing you have to do is to try to see whether or not some indicators already developed can be applied to your question at hand. How do we do that? That is a really simple Excel sheet that this author has gathered, and then you can use this Excel sheet to find out which particular set of indicators fits your purpose. So we are going to see how to use that sheet, and before we see that, we are going to see what is actually the substance of using such a tool to find a set of indicators. Okay, so what the author has essentially tried to do is to develop classification categories for these indicators. So here you can see that he has developed almost 10 different categories: levels, loops, performance. I'll explain to you more or less what these categories are first. So once you're faced with a problem, you can always ask these set of questions to determine which indicators suit you best. Okay. The first question you can ask is, what level am I talking about? Is it micro? Is it pertinent to a particular product or a particular firm? Or are we talking about meso level? Is it about these eco-national parks that we discussed during our industrial symbiosis lecture? Remember? Or are we actually talking about a whole city or a country? Then it falls under macro. So which particular loop are we interested in next? Are we trying to just focus on reuse or refurbish, repair, recycle? Or are we actually trying to prolong the life of the product, that is maintain? Remember in in performance economy, we talked about this, maintaining the stock. So, or it could be, as a matter of fact, we are interested in all the loops altogether and to see what's the effect. The other thing is we can have a set of selection based on either the progress, how something that we have conceived to be circular is going on, or a consequence. So for progress, we can give an example of increased resource efficiency as a result of the things that we have put forth in motion, or what is the net effect of what we have done to measure the consequence of an action that we have taken. So for instance, it could be resulting in reduced energy consumption. Remember, we covered this in remanufacturing a bit. So that could be a way to ask a question. And then we can ask a question about what is it used for? What actually is the purpose of the indicator? Is it a policy tool? Is it something that we have to communicate to the populace and say that look at the indicator and then decide for yourself? Is it something that you keep it internally to make a decision as a firm or a product producing company? You say that, oh, this is where the indicator shows us and this is where we have to go. So there are multiple ways we can ask a question about the usage of an indicator. And the next point comes about transversality. What does that mean? Is it an indicator that's developed for very particular aspect of circular economy? Let's say there are particular indicators that are developed for like construction industry. So those things cannot be obviously applied for, let's say, a printer or a mobile phone or whatever, right? Is it an indicator that is particular, or is it an indicator that is generic, can be used by everybody or for every aspects of circular economy? And then the question you ask about is the dimensionality. So is it like a simple single number? Let's say in the case of emissions, obviously that they are not circularity indicators, but I'm giving you an example. A ppm level is a simple number, right? You can immediately understand and relate to it. or it could be an indicator that is complex and developed only for experts to first understand and then explain to other people. So that could also be a case. Is it a quantitative indicator or is it a qualitative indicator? That's an important question. And the last point is that is the indicator developed based on a simple formula, mathematical formula, or do we have to click and go to a computational tool where we give all these inputs and then the tool takes care of actually deriving the indicator levels for us. So these are the set of questions that he has developed, and based on these things he has delivered a taxonomy. So to summarize again, it's about the levels, the loops, the progress or the consequence. Is it generic or particular? And what kind of dimensionality does it provide? Is it quantitative or qualitative? And can I just plug in my values and use a formula, or do I need to actually go to a computational based tool? So by asking these set of questions, he actually developed a taxonomy, and based on this taxonomy, we can actually get a set of indicators that is fit for our purpose. Okay, so this is the tool that he developed. The Excel sheet is attached to your reading material, I believe. So check in UV, it's already attached there. And I will teach you how to use the Excel sheet. It's pretty easy, it's fun. And please do it and then post the results as pictures or whatever. Okay, so it's for yourself to see. I will tell you how to play with it and then you can play with it. So this is the Circularity Indicators Advisor. So it's something that you could use to advise people or for yourself. So he has developed first a set of parameters, a set of things that you have to input. So they will ask you a several set of questions. The first is the scale of measurement and the perspective, performance, which loop do we want to target, and the dimensionality that I talked about. And all these things that I explained to you before will be asked to you as questions, and you need to make choices depending on what kind of thing that you have chosen, what is the question at hand. And then you'll get the output in a separate window within the same Excel. And there you'll get all the information about, so the description of the indicators and details about the level and the details about the level of circularity. And it will also provide you, interestingly, a website link. And you can click on the website link and then find immediately the indicator that you actually want to use and then start using it if it's so simple to use, for instance. Okay, so before I start this slide, I advise you to pause this video, go to University Virtual and download the Excel sheet that I have uploaded. Okay, so if you have actually done that, all you have to do is fill up choices in this drop down box. It's quite simple. So have a question in mind. Are you going to think about Eco National Park? Are you going to think about a city? Or are you going to think about a product? So for me, let's say I'm going to think about a product. Okay, I'm a particular business unit, let's say for some sort of printers of scanners, and then I want to try to develop a business model where you could have circularity in this printers use, and then have repair or refurbishing associated to this particular printer. Okay, so I'm just cooking up an example as I speak. You can take completely different examples. Do not stick to my example. So what you have to do is that first you have to answer this question. What level are we talking about? So I took a product, right? Is it micro, meso, or macro? Congratulations, if you answered it right, it's micro. Okay, and then are we actually talking about measuring the progress of circularity during the duration of development of the product, or are we talking about after, let's say we have designed the circular product and what is its impact? So so to choose that, you can choose whether it's potential or actual, that is effective circularity. And then we are going to evaluate the circularity performance. Are we interested in the intrinsic stuffs, that is the recirculation of resources and so on, or are we interested in the consequences of the developed product? So you can also choose between the consequence or the intrinsic, I always choose a consequence of my product to see how it has performed, so I choose impacts. Are you interested in one particular loop? Are you trying to focus only on, let's say, repair, refurbish, remanufacture, or recycle, or maintain? Or are you going to say, oh, I want to run all the loops? So you can choose. And then here, if you're really particular, let's say if you're particular about dimensionality, if you're particular, let's say if you chose a field which for a fact you know has really specific indicators, then you can also choose in transversality the particularity of indicators. If you want to choose only formulas, you can mention that, and so on. So fill in all these things in this drop down box in this Excel sheet and go here. Click this icon. Once you do that, it gives you the answers, the output of a set of indicators, and it gives you clearly the things that you can use by clicking the website link, and then you can go to the website link, read about the indicators, and see how it is used. Okay. And let's say in case you don't understand what I have told until now, or you are not interested in vague examples, then you can click on this YouTube link, which was uploaded by the author himself. It's very interesting because I have not seen YouTube links provided for articles, scientific articles. So it's interesting that I came across this. It is embedded in the scientific article he actually wrote. So click on this link and then see this YouTube video. He's the one who created this Excel sheet, and you could actually see the example of catalytic converter. Okay, he chose a particular example. He runs through all these things that is necessary for him, and then he derives a set of indicators. Okay, but it's not necessary that you stick to a product level. You can also imagine on a meso level or on a macro level, and then you will arrive at a set of indicators by your own. So clearly up to you. So until this point, what have you learned? You have learned that for a particular set of problems, let's say for a product or on a different scale, there are many circularity indicators that have already been developed. How do I know which one suits me best? The Excel sheet answers the question. What do those things in the Excel sheet actually mean? I have explained it to you in taxonomy, what they actually mean. If it is still clear to you, I have uploaded the article, and you can read from the article if you have doubt in one portion or the other in the taxonomy. Okay, so now with all this, you have developed the skill to choose the particular set of indicators. Okay, that is, let's say, the practical aspect of it. Now let's go and dive into a particular example, and then I will explain to you how people develop these indicators, or what is behind these indicators. Okay, so this is a particular example that I have chosen. Somebody has developed an indicator called as longevity. Okay, that's the circular indicator that we are going to take a look into for this particular lecture. We might choose different circularity indicators later down the line when we deal with recycling, but let's stick to longevity for now. So he has dealt with the problem of mobile phones, and he has developed an indicator called the longevity indicator. Okay, so the duration or the path length is actually the number of processes that is visited by a material within a product. So I have already explained to you what are the possible processes that a product can go through, right? It can have an initial lifetime, it can have reuse, refurbishing, recycling, and all these product lengths paths that I have indicated. So path length is simply the measure of the number of processes. So the longevity indicator, what it is trying to do is to tell you the length of time for which a material is retained inside a product system. Do you remember when I explained to you the butterfly diagram? It is basically about having the maximum value for a prolonged period of time, right? So longevity indicator is trying to give you a sense of that, some sort of quantitative sense of that, let's say. So you are essentially trying to have maximum resource exploitation and then have retention of that value inside that particular resource, right? So longevity is simply a sum of the initial lifetime, the refurbished lifetime, and the recycled lifetime in the case of the mobile phones that they are dealing with. It's as simple as that. Okay, it's not as simple. If you go to the article for each and every phase, they calculate a bit more in detail with a lot of, let's say, uh, careful stuff that they have to build up this equation into. But I'm giving you a sort of a qualitative idea of how they approach in designing an indicator. I hope you understand that. So it's essentially trying to understand how long does something stay within these bounds of these loops, okay? And what is the sort of retention of this value of this product? And if circular economy is all about maintaining these product inside these loops, then higher the longer the longevity, it is more circular intrinsically. So that's the idea behind developing such an indicator, okay? So they have tried to do it for the mobile phones life cycle here. So in EU, I think it's more or less 2 years of initial lifetime for a mobile phone. I think it's the same for US as well. So the initial lifetime is almost 2 years. So during my PhD, I was put in a recycling company for 1.5 months as an intern, as a part of my secondment. It was Stena Metal in Sweden. So basically what we are trying to do is trying to separate these rare earth containing magnets from various devices such as electric tools and stuffs like that. Completely different project. So why am I saying that very randomly? I'll give you an example. So at that time was the release of iPhone 6, I guess. And in this waste bin that we were gathering from all over Sweden, I saw a lot of iPhone 5s. So that's just one model before. Okay, so the initial lifetime of a mobile phone, as we all know, has nothing to do with the performance as an indicator, right? It's just people try to catch up with technology and throw out stuffs, even though they can be very useful. In fact, I have a calculator that I took from that waste bin that has lasted long for all my PhD, all my postdoc, and still I'm using it as an assistant professor. So you could imagine, it's a lot of useful stuff that are thrown away. Anyways, let's not digress, and I will come back to the stuff that I'm talking about. So the initial lifetime is important to know. It's just 2 years for a mobile phone, and worldwide we are talking about less than 3% of mobile phones getting recycled. Okay, so you have this normal loop, and what happens after the end of life? You either have a market control mechanism where it could be returned to the operator, or it could be donated by the consumers to a charity, or so on and so forth, or it's completely out of the market-borne control, where it is simply thrown off or disposed by the consumer or stockpiled for a long time and so on. Okay, and then you also have this other loops such as refurbishing, recycling, and then reselling these phones and so on. One thing you have to notice is that, as I told you, a lot of these phones still work after their end of life, like not typical end of life, after they are thrown away, let's say, they still work. And the material loss, especially in recycling, when you try to recycle these phones, is really inevitable. Think like you can have almost, in this study, they say that the BAT, the best available technique, can recycle 95% of stuffs from mobile phones. We will get to that number later, but just let's say that's true. You can have an effective recycling process for recovering a lot of these precious metals inside these mobile phones, but there are a lot of tricks to it, because a lot of these metals, after 2 levels of recycling, that is, if you recycle it twice after it goes into a product and then it comes back, you simply lose almost all the metals. It gets dissipated. It's just vanishes. And the reason for this vanishing behavior is multifold. Essentially, the first step to recycling, people think that making recycling processes more efficient is the most important bottleneck, but that's not true. The first and most important bottleneck is collection. The collection of these things are really, really difficult and very dissipated and very diffuse, and therein lies a huge problem. Okay, so what did they find by using these longevity indicator? what they found was that only 15% of these phones were even returned, and out of them a few percentage were refurbished, and then you have a huge amount of precious metals recovery. Okay, but what they found was you have the initial lifetime of a fresh mobile phone for 24 months, right? The refurbished phone lasts even less. It just lasts for a year. There's just 12 months. Okay, you have the sort of this material degeneration that I talked about, but also tech obsolescence. It's basically people think, or could be true, that the new model is so functional than the previous model. The older model just become completely really non-functional in the perspective of consumers. Okay. So you see here in this diagram various loops. You have the initial lifetime, the refurbished, recycled, and the reused lifetime, and all these other things. What they found was that the total longevity was 27 months, almost less than 28 months. Okay, and there are many reasons for not this sort of extended longevity than the initial lifetime. And one thing they found is concerning the refurbishing. I'll come into that in the next slide. So essentially, we all know what are the remedies for it, but one thing they really found as a crucial aspect was that the refurbished phones, okay, refurbishing is a process of extending the life of a product within the cycle or the loop of circular economy, right? That's true. But on the other hand, what is happening is that these refurbished phones are not being returned, okay? The mobile phones that you initially use are at least getting returned and then going through either refurbishing or recycling processes. But if the refurbished phones are not even getting back into the market or getting back into this loop, then you essentially lose material. So that means that refurbishing, even though notionally it has a positive impact, on the whole can even have negative impact because of the fact the phones are not simply coming back. Okay, so it's not all about designing cool processes, designing greatly efficient techniques to recover these metals, to recover these key ingredients. It is also about the fact that you have to design an entire system through policy. Okay, you have to ensure on a policy level how do we tackle these issues. Okay, so we all know that longer the product lifetime, better it is, and more return, effective recycling can all contribute to extended longevity. Okay, but one thing they actually assumed could not be true here, because you see what they are assuming is that in calculating this longevity indicator is that the recovered material can be reused back in the same product. That is something of a metal that is recovered from a mobile phone can be used again inside a mobile phone. But that may not be true. The mobile phone has a multitude of various elements. The cobalt that is present in the mobile phone's battery can be recovered in a facility in Yumiko and simply go to something else. So the reuse part of these materials back into the original devices may or may not be true. So the assumption is questionable there. Okay, so what we have covered thus far, I told you what are indicators, what are the classifications of indicators. I gave you an Excel sheet to see which indicator you can choose to your own question. And I showed you how somebody developed an indicator of longevity when it comes to mobile phones, which is an indicator for circularity. And having said all these things, it's also important to analyze indicators critically, okay? Indicators are made by humans and they can be wrong. So if something is circular, does it necessarily mean it is sustainable? Does it really necessarily mean it's sustainable? Maybe or maybe not. So there you have to have your mind open to ask critical questions to it. I have a really interesting article to share with you at the end of our lecture series during the criticisms on circular economy. A group from Singapore really interestingly published a work in Nature Sustainability on sustainability indicators. What they found was sustainability indicators show, for a lot of cases, no real correlation to sustainability, and sometimes it's diametrically the opposite. The better an indicator is, less sustainable the reality is. So remember the sustainability indicators are developed and for a long period of time, and it's inside the official framework of UN. So it's always good to have a critical viewpoint on the sustainability or the circularity indicators, okay? And a lot of times they don't take into account the social dimensions. You have, importantly, you see, I told about longevity indicator, right? It's not a monetary indicator. See, it doesn't give you any impact on economic benefits. It just gives you an idea about intrinsic, or like, let's say, the circularity of something, okay? So indicators can tell you many different stories. It may or may not hint at the economic benefits. It may or may not take into account social dimensions. So you have to think about all these things holistically and critically. So that's all for the lecture of circularity indicators. I hope you understood most of it, and let's see in the next part of the lecture.